think fusion has a vital role. In fact, I find it quite hard to see how we can achieve net zero in 2050 without it. But there are a number of private sector companies pursuing fusion now, and are expected to become commercially deployable during the 2030s and to play a substantial part in the energy mix in the 2040s. The issue here is that we can go a long way towards electricity decarbonisation with renewable energy. But wind and solar are intermittent. We need a fallback when the wind isn't blowing or the sun isn't shining. And filling in these gaps in the required generation profile is difficult and expensive. Battery technology can't really do the job. We also need a solution to the decarbonisation issues further down the road of industrial process heat, domestic heat, transport, and hydrogen production. The best approach is to combine intermittent generation with baseload power, which runs continuously when it's required. But other than fusion, the only options for baseload in a net zero world are conventional nuclear fission and gas generation with carbon capture, utilization and storage. Nuclear fission has major issues with safety, decommissioning and long-term waste disposal, while CCS is expensive and requires large-scale secure storage in reservoirs to deal with the carbon dioxide that can't be used in other processes. So fusion offers the prospect of safer, cleaner baseload generation, which can be flexibly situated near to centers of demand. Used in combination with large-scale deployment of renewables, it could provide an outcome which is cheaper and more efficient in overall system terms by reducing the total generation capacity required, reducing the amount of network investment linked to that, and involving substantially less land use for generation. Now, all of that is true in all parts of the world, but I think fusion could be particularly important in Asia, where there are a number of countries that will find it difficult to achieve net zero by reliance on renewables and storage. And I think Japan, and for that matter Singapore, are good examples of this. Our approach has two aspects which we believe make it the best route to achieve commercial fusion. These are a spherical tokamak reactor design and the use of high temperature superconducting magnets, HTS magnets. And we've made major advances in both areas in the last couple of years. So Tokamak Energy has been operating spherical tokamaks for several years. And earlier this year, our ST40 device achieved a plasma temperature in excess of 100 million degrees centigrade, which takes us into the range that's needed to achieve successful fusion. That result was validated by a panel of independent experts in the field. But the ST40 uses conventional magnets to contain the plasma, and there are limits to what can be achieved by this approach. So in parallel, we've been developing the HTS magnets, which are much more efficient and allow more compact tokamak reactor designs with significant potential capital expenditure savings. In 2020, we achieved a magnetic field of 24 Tesla with our HTS magnets in our own labs. And we then sent them to CERN in Switzerland for further testing, where a 26.2 Tesla field was achieved there. So our next device, which will start commissioning in about 4 years' time, will combine our spherical reactor design with HTS magnets and will be a major step towards a commercial fusion reactor. We then plan to construct a commercial pilot plant in the early 2030s, with commercial deployment in the second half of the decade. As I hope I've indicated, fusion is potentially the missing piece in the jigsaw on the road towards energy decarbonisation. It provides a potential source of emission-free baseload generation, which will complement large-scale deployment of renewables and address the deeper decarbonisation challenges to come. It has other advantages. First, it's safe. The reactor fails to safety, by which I mean if anything goes wrong, the process stops naturally. Tokamak reactors do produce some nuclear material that has to be disposed of, but no long-life, high-level waste. In recognition of that, the UK government recently decided that fusion should be regulated by the Environment Agency and the Health and Safety Inspectorate, rather than the Office for Nuclear Regulation, which oversees the conventional fission industry. And this places fusion under the same regime as many conventional large-scale industrial processes and sectors. Perhaps equally importantly, in the current environment, fusion can be a big contributor to energy security. It requires no large-scale imports of fuel, and the materials necessary for fusion are not dependent on small numbers of high-risk suppliers. Finally, also, much of what I've said could apply to other fusion companies. We believe that Tokamak Energy's unique proprietary technology is the best place to achieve commercially viable fusion on a timescale to contribute to a resilient and sustainable energy future.